Sketch the graph of the greatest integer function. The greatest integer function is the function that gives an output that is an integer. But this integer as an output has to be the greatest, it has to be the largest of all of the integers that are less than or equal to the input. This is why the greatest integer function is also known as the floor function, and so it is below. For example, if we plugged in 2 into the greatest integer function, the integers that are less than or equal to 2's are 2, 1, 0, -1, -2, and so on. Out of all of these integers, the greatest of them all is 2. If we plugged in 1.7 into the greatest integer, the integers that are less than or equal to 1.7, now 1.7 is not an integer, so the integers that are less than 1.7's are 1, 0, -1, and so on. Out of all of these integers, the greatest of them all is 1. If we plugged in 1.2, the integers that are less than 1.2's are 1, 0, -1, -2, and so on. And out of all of these integers, the greatest one is 1. Notice that the greatest integer function is not a way of rounding numbers at all. Now, if we plugged in -1.2, the integers that are less than -1.2 on the number line, they should be on the left-hand side of -1.2. They are -2, -3, -4, and so on. And so, the greatest of all of these negative integers that we just listed is -2. -1.9. If we plugged in -1.9 into the greatest integer function, then the integers that are less than -1.9, again on the left hand side of -1.9, so -2, -3, -4, and so on. And out of all of these negative integers, the greatest of them all is -2. Keep in mind that if we were to plug in an integer into the greatest integer function, the answer is an integer. And if we plug in a decimal number, then we'll just simply look at the floor of that integer. And so, to graph the greatest integer function, if an input is an integer, then an output is an integer as well. And so when x equals 0, y equals 0. When x equals 1, y equals 1. When x equals 2, y equals 2. When x equals 3, y equals 3, and so on. When x equals -1, y equals -1. When x equals -2, y equals -2. When x equals -3, y equals -3, and so on. Now, any number between 0 and 1, but not including 0 and 1, we would look at the floor or the integer below it. So, for example, 1.2, the greatest integer is 0. 1.9, the greatest integer is 0 as well. And so, for any number between 0 and 1, the greatest integer is 0. Now, the greatest integer of 1 is already 1, so we need to exclude 1. And so the endpoint for that line segment is an open circle. Similarly, for any number between 1 and 2, for example 1.5, the floor of 1.5 is 1, the integer below it, and so we would graph 1. And similarly, we would use an open circle on the right endpoint. All of these has an open circle on the right endpoint. And so this is the greatest integer
function.